Hey there, and welcome to This Explainer. Today, we're jumping straight into a super exciting topic, building long-running AI agents. We're finally moving way past those basic one-off chat interactions. We're stepping right into the era of building genuinely smart AI agents, agents that can actually manage complex workflows that take days or even weeks to complete. So let's dive into this. What exactly happens to your AI when a task takes, say, 3 weeks? Imagine the friction of making an AI manage a real-world business process. Let's take HR onboarding, for example. You've got a new hire, right? And you need to send them a welcome packet. But then you have to wait. You might be waiting 3 whole days just for them to sign their documents. And then you might be waiting another week for their hardware to be delivered. So what happens to your AI during those 3 weeks? Back in the day, trying to build an agent for this was just a total nightmare. You basically had to either keep the system running constantly, just burning through compute, or you'd shut it down, and the AI would completely lose its mind and forget its context by the time the human finally clicked sign. To really wrap our heads around the solution, we need to contrast the two approaches. Standard, stateless chatbots live entirely in their short-term memory. Literally, if you close the window or the server restarts, boom, they die. Over a long task, they suffer from what we call token bloat. That basically means they just burn through their context windows trying to remember everything that happened days ago. But long-running agents, they're entirely different beasts. They maintain a durable state. They can actually survive for weeks across multiple server restarts, and they maintain a perfectly clean context. Why? Because their unit of work isn't just a single text prompt anymore, it's an entire multi-step workflow. So the crucial point is that because of how they're built, standard agents inevitably hit 3 specific, massive walls when you give them long-term goals. First up, context degrading. Even if you have these massive context windows, filling them up with days of idle chatter or constant status checks leads to a huge drop in reasoning quality. Second, no persistent state. Without a structured external memory, agents just drift, they break, or they literally just give up entirely. And third, no self-verification. If a task drags on for a week, the agent often just hallucinates intermediate steps, pretending a task is done just to satisfy the prompt. We absolutely need a way to break through these walls. And that brings us to Section 1, Meet Long-Running Agents. So we're looking at a completely new architecture here. Through advancements in tools like Google's Agent Development Kit or ADK, we are shifting from agents that just answer questions to agents that own an end-to-end multi-day process. The foundation of this ADK architecture rests on 3 core pillars. First is durable state, meaning the agent's progress is saved, kind of like a video game checkpoint. Second is event-driven dormancy, which lets the agent essentially turn itself off while waiting for the real world to catch up. And third is multi-agent delegation, ensuring that one single agent doesn't get totally overwhelmed doing every little microtask. These 3 pillars are exactly what makes multi-week AI workflows possible. Let's put this into practice. Section 2, Case Study. HR Onboarding Coordinator. This isn't just a simple script we're talking about. This is an orchestrator agent that owns a complex, multi-day process from the exact moment a candidate accepts an offer, all the way to their very first day on the job. And this brilliantly illustrates the exact sequence the agent must flawlessly own. Step 1, send the welcome packet. Step 2, wait for the new hire's signature. Step 3, confirm the laptop has been physically delivered. And Step 4, create a personalized day 1 schedule. The agent has to run these steps in the precise order that the state machine dictates. It absolutely cannot be coerced into skipping ahead. Like, no way can it schedule day 1 if the laptop hasn't even arrived yet. Now, here is where the absolute magic happens. The agent executes Step 1. It calls the Send Welcome Packet tool, it logs that activity in ADK, and then it just completely halts execution. It stops dead in its tracks. It hits a pause gate. There is absolutely no active polling loop happening here. There's no threads spinning endlessly in the background constantly asking, did they sign it yet? Hey, did they sign it yet? The agent just completely stops. Which brings us to a formal definition of our second pillar, event-driven dormancy. The agent goes fully dormant. It halts execution entirely, without thread spinning, just waiting for an external event, like a webhook from the employee portal, to wake it back up. By doing this, we completely prevent token bloat, we prevent compute waste, the container running your agent could literally crash, your entire server farm could restart, and it wouldn't even matter, because the agent isn't running at all, it's just waiting in a state of suspended animation. I absolutely love this quote from the source material. An agent has to truly be able to sleep. It's a lot like a person. Seriously, think about that. If you were managing this HR process yourself, you wouldn't just stare at your inbox for 72 hours straight waiting for a signature, right? Of course not. You'd go to sleep, you'd work on other things, and you'd just wait for a notification. For long-running workflows to actually succeed, we have to design our AI systems to do the exact same thing. Now, what's really interesting about this slide is how we actually achieve that sleep without the AI losing all its memories. The secret is that first pillar, durable memory schema. In ADK, state is stored as a strict enum in a database. It is definitely not some messy pile of raw JSON chat logs just dumped into a vector store. When the agent goes to sleep, its exact place in the workflow, for example, a status of waiting for signature, is hard-coded durably. This means zero context pollution and literally zero risk of hallucinating steps that haven't even happened yet. Moving on to Section 3, true sleep and waking up. So the server might have rebooted and days have passed, but eventually the new hire finally signs their digital welcome packet. How does the sleeping agent come back to life to finish its job? The answer is the ADK resume turn. Look at the trigger on one side, an external event like a webhook firing from your employee portal, or maybe an API callback from a shipping provider confirming laptop delivery. Then look at the action on the other side. That webhook hits your system and triggers an ADK resume turn. The most fascinating part here is that in a proper setup, your HR dashboard UI shouldn't even optimistically update. It deliberately waits for this exact ADK resume turn to complete on the back end before showing the next step. It's the proof that the agent is genuinely reading its durable state and making the cognitive leap to the next phase. Let's move along and see how this builds across a real-world onboarding timeline. Okay, so day 1, the packet is sent and the agent goes to sleep. Nothing at all happens on day 2 or day 3. Then, on day 4, the webhook is received, the ADK resume turn fires, the agent wakes up, perfectly reads its durable enum state, sees that the signature is complete, and flawlessly transitions to day 5, provisioning the IT accounts and hardware. Zero tokens were wasted during those 3 days of waiting. None. Which naturally leads us to Section 4, multi-agent delegation. But wait, tasks like provisioning IT accounts are pretty complex on their own. Does our coordinator do all of this alone? Absolutely not. To keep its own reasoning chain perfectly clean, the main orchestrator agent delegates these subtasks to specialized sub-agents. It can pass the context off to an IT provisioning agent, or maybe a hardware delivery verifier agent. This is just brilliant because it completely prevents the main coordinator's context window from getting polluted with stuff like API keys for shipping companies or technical jargon for software licenses. Every single agent in the workflow stays focused, targeted, and totally clean. And finally, Section 5, the future of workflows. Taking a step back here, we are now treating AI like a reliable digital colleague that can manage asynchronous real-world delays just like we do. So here are your big takeaways from this explainer. By leveraging durable memory schemas and event-driven dormancy, your agents can now survive server restarts smoothly. You are going to see zero hallucinated intermediate steps because the state machine keeps the AI strictly on its tracks. And honestly, most importantly for your infrastructure bills, you will see zero compute wasted during those long waiting periods. We have permanently fixed the massive headache of managing asynchronous AI delays, which leaves us with a pretty incredible reality. The technology is here right now, and it's open source. So I want to leave you with this final provocative thought. If your AI can sleep securely for weeks, wait patiently for humans to act, and then wake up right on cue with absolute perfect memory, what complex human workflow are you going to automate next? The possibilities are literally endless. Thanks so much for joining me in this explainer, and I seriously can't wait to see what you build.